Hi, this is the fourth in my series of exam review videos, and it is on applications of Newton's laws. We will talk about mass and weight, which we also just talked about in part 3. We'll talk about the normal force, which we also talked about in part 3. Friction, tension, springs, forces, systems of objects, forces on incline, centripetal force, and gravitation. Okay, find the weight of a 12. First of all, let's talk about the difference in mass and weight. Weight is a force, and it's measured in newtons. Mass is a characteristic of an object that is how much stuff is in it, and it is measured in kilograms. And weight equals mass times gravitational acceleration. So if I want to find the weight of a 12 kilogram object, then that would equal 12 kilograms, the g times 9.8 meters per second squared, and 12 times 9.8 is that 12.8 equals 117 newtons. Okay, 117.6 newtons. Find the mass of a 100 Newton object. Well, if weight is mass times g, then mass is weight divided by g. So it's 100 newtons divided by 9.8 meters per second squared. 100 divided by 9.8 is 10.2. 10.2 kilograms. The normal force. The normal force is a reaction force. It is a support force. So if you have an object sitting on the table is pushing up on the object with the normal force. The direction is not always up. It is perpendicular to the surface. So if I have a book sitting on a table, then the normal force is up. But if I have an object sitting on the incline, the normal force is perpendicular to the incline. So not always up, but always perpendicular to the surface. Find the normal force on a box in an elevator accelerating upward at 1 meter per second squared. Okay, so here's my box, and let's draw a free body diagram. That box has a normal force acting on it, and that box has weight. It's accelerating upward, so I'm going to let my normal force be bigger. And my sum of the forces equals ma equation would be that the normal force minus the weight equals ma. And I'm looking for the normal force, so the normal force equals ma plus the weight, which is mg. That weight right there is mg. And so that equals, I left off the mass. So let's say a 2 kilogram box. So 2 kilograms times, upward would be a positive acceleration, 1 meter per second squared, plus 2 kilograms times 9.8 meters per second squared. 2 times 1 is 2. 2 times 9.8 is 19.6. And so 21.6 newtons would be the normal force. What if the elevator is moving with a constant velocity? If the elevator is moving with a constant velocity, then the normal force vector and the weight vector have to be equal and opposite. So the normal minus weight equals 0 because there's no acceleration. And so the normal force equals the weight equals mg equals 19.6 newtons. Friction, force that resists the motion of objects sliding against each other. The direction, the friction force always opposes the motion, so it's in the opposite. The force is in the opposite direction of the motion. Types, there is static friction and there is kinetic friction. The equation is the frictional force equals mu n. Mu, it's the Greek letter mu pronounced, and that's how you spell it, mu. And that is the coefficient of friction. For static friction, this equation is the maximum frictional force. So if I had a big heavy box and I'm trying to push it with a force in this direction, you know, if I start with a little tiny force, that box isn't going anywhere. So if I have a little tiny force, the box is just going to sit there, and that's because the frictional force is as big as the force that I'm pushing. So the frictional force starts at 0 if you're not pushing on it. And as I push harder and harder and harder, the frictional force gets bigger and bigger and bigger, and it grows to mu n. So this is a maximum. The maximum that the static friction force can be. So when you first start, the frictional force is equal and opposite to what you're pushing, and there's no acceleration. And then when it gets to be this big, that's when the box starts to move, and the friction changes from static friction to kinetic friction. Remember, the coefficient of friction only depends on the two materials. The coefficient of friction does not depend on surface area, it does not depend on weight, it only depends on what the two materials are. The actual frictional force depends on the materials and the normal force, the weight. So the coefficient is a characteristic of the materials. The force itself depends on both the materials and the weight of the object, or the normal force acting on the object. Calculations. Find the maximum static frictional force if mu s static friction coefficient is 0.3 and the weight of the object is 4.5 newtons. It's sitting on a horizontal surface. So the maximum static friction force is going to be mu times the normal force, and if it's on a horizontal surface, then that normal force and the weight are equal and opposite. So the normal force, they both equal mg. And so that's going to be mu mg equals 0.3 times, oh, well, I'm sorry, it's already in newtons. So that is mg, 4.5, and 0.3 times 1.35. And that's newtons because it's a force. Find the frictional force if the weight is 35 newtons and the coefficient of kinetic friction is 0.45. Again, we're on a horizontal surface, and that just means that the weight is equal to, and the normal force is equal to the weight again. So we have the frictional force equals mu times the normal force equals 0.45 times the normal force is the weight, which is 35. And 0.45 times 35 equals 15.75 newtons. Does the pushing force on a stationary object affect the maximum frictional force? No. But the actual frictional force, yes. So if this guy is pushing this box that has a certain coefficient of friction with the ground, that frictional force will be equal and opposite to his pushing force until his pushing force gets as big as mu n, gets as big as, that maximum force. So the actual frictional force that's being experienced does depend on the pushing force, but the maximum that it can be does not. Does adding a mass to an object affect the maximum frictional force, the actual frictional force? So, yes, because the maximum frictional force is mu n, that normal force, and if I add mass to an object, it will increase the normal force. So yes. The actual frictional force, yes. Find the coefficient of friction if the frictional force is 2.5 newtons and the normal force, or the horizontal surface, the normal force is equal to the weight. So if F equals mu n, that means mu is equal to F over n, which is equal to 2.5 divided by 9.5. 2.5 divided by 9.5 equals 0.26. 0.26. And there aren't any units because this is newtons divided by newtons and the units cancel. The tension force is a force that's applied by a rope or a cable or a cord or yarn or a string or anything like that. It can only pull and not push. What is the tension in a string that is holding a 3 kilogram box not moving? So I have a 3 kilogram box suspended by a string. If I drew a free body diagram, I've got the tension up and the weight down. And if it's not moving, it's also not accelerating. And that says tension minus weight equals 0. And so the tension equals the weight, and that equals mg. So 3 times 9.8 meters per second squared. Times 9.8 equals 29.4 newtons. What is the tension in a string that's accelerating a box upward? Okay, so now in the free body diagram, the tension is greater than the weight, and tension minus weight equals MA. Tension is equal to weight plus MA, which is mg plus MA. And so it's the same box, 3 kilograms times 9.8 meters per second squared. And I know from up there that's equal to 29.4 plus 3 kilograms times the acceleration, which is 1, plus 3, 29, so 32.4 newtons. What's the tension in a string that's accelerating the box downward? Well, if it's accelerating the box downward, the weight is bigger than the tension force. So tension minus weight equals MA. So tension is weight plus MA. So that's mg plus MA. Let's come up here, and that's 3 times 9.8 plus the mass is 3, and now the acceleration is negative, so minus 1. So that'll be 29.4 minus 3 equals 26.4 newtons. Spring forces. K is called the spring constant. The negative sign is because the spring force, the force that the spring is exerting, and the displacement are always in opposite directions. Find the spring force if displacement is 4.5 meters and the spring constant is 25 newtons per meter. So F equals minus Kx equals 25 times 4.5. 25 times 4.5 equals 112.5. Put that negative sign there. Negative 112.5. And again, that's just saying that it is in the opposite direction from the displacement. If you stretch it, the spring's sitting there, if you stretch it out, you're displacing it this way, and the spring is trying to pull itself back that way. So those two, the distance and the spring force, are always in opposite directions. If you are having trouble with systems, there is a video that should be posted in the news feed. You can also find it at my YouTube channel, all about systems. I will work this example. The first step is to make a free body diagram of each object. So I'm going to call this object 1 and object 2. Object 1, you have tension in this direction, and you have weight, and you have the normal force. Those are equal and opposite. They do not contribute to the acceleration, so I'm not going to do a sum of the forces equation for the vertical part here. And this object, we have its weight in 2g and tension upward. So write a sum of the forces equation. In this one, for object 1, the forces are just the tension, and that equals M1A. For this one, the sum of the forces on object 2 would be M2G, the weight of this object, minus the tension, equals M2A. The A's are the same because the objects are connected. And what else? Oh, the tensions have to have opposite signs. If it makes this thing rotate clockwise, then it's positive. And if it would make it rotate counterclockwise, it's negative. And so this tension is a negative tension, and this tension is a positive tension. So make a substitution, and put, if tension equals M1A, I can put M1A there. And so I get M2G minus M1A equals M2A. And I want to solve for acceleration, so I need to move this term over there. So M2G equals M1A plus M2A, or M1 plus M2A. And if I want to solve for acceleration, I divide both sides by M1 plus M2. And they cancel out here, and I have acceleration. So my acceleration is the mass of the second object, which is 5 kilograms, times gravitational acceleration, which is 9.8, divided by the sum of the two masses, and that's 15 kilograms, 10 plus 5. And let's see, I can see that I'm going to cancel the 5, 3 there, so it's just 9.8 divided by 3 is 3.3 meters per second squared. And now I need to substitute this back in and find the tension. Into this equation would be the easiest way because tension equals M1A, and that's just equal to 10 kilograms times 3.3 meters per second squared, which is 33 newtons. Inclines. I also posted a video only on inclines in the newsfeed. So if you need more than I'm giving you with this video, then go back and look at that. Things that you need to know. If you have no friction, the acceleration of an object at an incline is just g times the sine of theta. The perpendicular component of the weight is mg cosine theta, and this angle and this angle are the same. The component of the weight that is parallel to the incline is mg sine theta. The normal force will equal the perpendicular component of the weight and will be equal to mg cosine theta if you need the normal force. What happens is the slope changes. Well, if the slope gets small, then the perpendicular component of the weight increases and the parallel component decreases. If the slope gets steeper, then the component down the incline gets bigger and the component perpendicular to the incline would get smaller. Find the acceleration given an angle. If there's no friction, what is the acceleration if the angle is 30 degrees? Well, the acceleration is g sine theta, and that's 9.8 times the sine of 30 degrees. And the sine of 30 degrees is 5. 0.5 times 9.8 is 4.9. So that's equal to 4.9 meters per second squared. Find the angle from the acceleration. Find the angle if the acceleration is 6 meters per second squared. So sine theta would be equal to A over G. I just solved this equation for sine theta. And so 6 meters per second squared divided by 9.8 meters per second squared. 6 divided by 9.8 is 0.6. 0.61, and so the inverse sine of 0.61 will give me my angle. So inverse sine, I get an angle of 37.8 degrees. Be aware that if an object is at rest on the incline, then the acceleration is 0. So if you have a problem that's set up, have an object at rest on an incline, then the acceleration is 0. So that's a little bit tricky because it'll give you values and you'll want to find an acceleration. But if it is at rest on the incline, the acceleration is 0. Be prepared. In our last slide of this presentation, easy peasy stuff, centripetal force. The centripetal acceleration is v squared over r. Force is mass times acceleration, so it's m v squared over r. M is the mass in kilograms, r is the radius of the circle, v is the velocity in meters per second, and Fc is the centripetal force. The centripetal force is not a new force. You would never put it on a free body diagram. Other forces that we've had before, like tension and weight and the normal force and friction, provide centripetal forces. So it's old forces that we've had acting in a new way. The force is towards the center, and it only changes the direction of the velocity, not the speed. So the speed will be constant as it goes around, but it's accelerating because the direction is constantly changing. Never ever put a centripetal force on a free body diagram. Don't ever label a force centripetal on a free body diagram. Finding velocity from circumference. Well, remember, velocity is distance over time. And so if it's going in a circle, that's equal to the circumference divided by the period, actually, the time it takes to go around once. So if the circumference is 0.85 meters and it takes 2.5 seconds to go around one time, then the velocity is 0.85 divided by 2.5 is 0.34 meters per second. Find the centripetal force if the mass is 3.5 kilograms, The radius is 2 meters and the velocity is 15 meters per second. So F equals mv squared over r, and that equals 3.5 kilograms times 15 squared divided by 2. So 15 times 15 times 3.5, divide that by 2, I get 393.8. And that would be newtons. Forces that are causing centripetal force. In this is an object that's being swung in a vertical circle. When it gets to the top, the centripetal force is equal to the tension plus the weight, because the tension in the string is acting towards the center, and the weight is also acting in that direction. And so since they're in the same direction, they add together to equal the centripetal force. At the bottom, however, the weight is acting downward and the tension is acting upward, so the force that's towards the center, the centripetal force, is the tension minus that weight. On either side, the weight is perpendicular to the tension, so it's in a different dimension. And so it's the centripetal force is the force that's towards the center of the circle, and so the weight is not towards the center or away from the center, and so the centripetal force is simply equal to the tension in the cord. And that is the end of review part 4.